Hey guys, welcome to today's video. Today's video, you're gonna learn how to build multi-agent applications using Qwen models. Some of you might be curious how multi-agent applications work, so I'll explain it to you now. So as the name suggests, a multi-agent application consists of multiple agents. In my example here, there's an image generator agent and a web searcher agent. They both are managed by a manager agent, so depending on the user's query. So for example, if the user tells the manager to build an image, the manager agent will propagate this query to the image generator. Similarly, if the user tells the manager to search some stuff on the web, the manager agent will direct this query to the web searcher agent. So as stated in my previous videos, an agent can have tools. So for example, the image generator has an image generation tool, and the web searcher agent can have the visiting web page tool and the web search tool. Now that you know what multiple agents are and how they work, let's now head to Google Colab to write some code. So my first step would be to install Ollama. I'll now head to another tab to open the Ollama website. I can just copy this command and then exclamation marks for a bash command. So then I install Ollama. I'll create another code snippet to start the Ollama server. So import subprocess, import time, and then subprocess the open. It's p open Ollama, serve. I'll create another code snippet to install Ollama models. So for this video, I'll be using Qwen3 models. Qwen3 in my experience has been the easiest to work with. So to install Ollama models, I simply go Ollama pull Qwen3 14 billion. I'll use the 14 billion parameter. And for web searching, I'll use the 8 billion parameter model. Ollama pull Qwen3 8 billion. Next, I would want to install my dependencies. So I create another code snippet and pip install Smolagents toolkit, LangChain community, LangChain Hugging Face. So I want to import tools from the Hugging Face hub. So Hugging Face, and then there's another dependency, Hugging Face hub. In some cases, I would also need to install transformers. So I'll install it now, transformers, and then here is an exclamation mark. Let's now run all of this code one by one. So I reconnect to my instance, then run all of this code. So while my code runs, let's create another code snippet. I want to create a tool for my Qwen3 model to visit certain web pages. So to create a tool, I simply go at tool, the tool decorator, and then def, I visit the web page. So visit web page function. And then my parameter. So my first parameter is going to be the URL of the web page. So URL. Let me scroll down. Let me zoom in also. It needs to have type annotations, otherwise small agents won't be really happy when I run it. And then str. So I need to create documentation, so I'll do it now. 3 apostrophes, and then here I write my documentation. So visit web page at the given URL and returns its content as a markdown string. Now for my arguments. So args URL, the URL of the web page to visit. I'll also need to add a returns section. So it returns a string, and the string is the content of the web page converted to markdown, or an error message if the request doesn't work. And then for my actual function, so I do try. So I store the web page content in response, and then requests, so get. So I request the website, so I pass in my URL. And then if there's an error, I use the raise for status function. So raise for status. Now I want to get the markdown content that will help the AI agent process information. So I do markdown content, markdownify, response.text, and then I strip it. So what I'm doing here is that I'm converting all of the HTML content to markdown, and then I return markdown content. Finally, I handle my exception. So accept request exception as E, and then I just print. So return a template literal, error fetching web page, and then convert the exception to a string. There can be another exception as well. So accept exception as E. So catch all general exceptions. So return F, error occurred, and then same as above. Now I have some errors. I would need to fix my code. So I import the request package. I import markdownify. So from markdownify, I import markdown down, if I from requests the exceptions, I import request exception. And finally, for my tool decorator, from Smolagents, import tool, and then I run this code. So running it, I don't have any errors. Let's now move on to actually using this tool. So from Smolagents, import code agent. So I want my code agent. I want another agent to call tools. So tool calling agent. And then I want my web search tool as well. This will be the tool that will search the web. And then since I want to use custom AI models, I will import OpenAI server model. OpenAI server model. Let's declare a few variables. So for example, for my reasoning model, I'll have a reasoning model name. So in this case, it's going to be Qwen3, 14 billion. Let me scroll down. And then my tool model, Qwen3, 8 billion. So I need another function to get my model. So def get model. And then in the parameter, it's going to be the model ID. So I use my OpenAI server model to get the actual model. So the model ID is coming from the parameter. My API base is the URL of where the Ollama server is running. So it's simply http localhost 11434/v1. Since it's local, my API key is going to be Ollama. Let's now get our models. So I'll say tool model is my tool calling agent. So it needs a series of tools. So tools and an array, so it can be multiple tools. So I'll simply go web search tool. So for searching the web, and then to get the content of that web page, I'll use my visit web page tool. So visit web page. Next, I need to actually get my model. So model, so it's simply get model and my tool model name. Next, I want max steps. Let's say 5, or it's better to give it actually 3 steps, because the more steps you give, and sometimes in some cases what happens is this model ends up hallucinating. Moving on, now I need a name for this model, so I'll call it web search agent. It also wants a description, so I'll go runs web searches for you. Next, I would want my reasoning model. So reasoning model. So I would want my reasoning model to be good at reasoning, obviously. So here I'll be using code agent. So my code agent will be used to manage this tool model. So first of all, I don't want any tools by default. I want my model. So get model and then my reasoning model name. Next, I want my managed agents. So in this case, since my reasoning model will be managing the tool model, so I'll pass it like so. It's an array, so it's tool model. And then my next step would be to specify if I want any additional imports. So I'll do it now. So additional authorized imports. So in some cases, I would want a few imports. So time to process time when visiting a web page, NumPy and pandas. I'm importing both of these modules because I want my managed agent to also perform data analysis. I think we're mostly done here. Let's now run this code. Okay, so no errors so far. Let's now test it out. So I'll run the reasoning model, run. Let's now give it a query. I want to see if it actually calls my tool model. So I want to ask it to make a web search. So let's say, please tell me about the sales of the latest MacBook Pro. And then I run it. Let's now see if it works. So after a few minutes of processing, I got an answer. But now let's look at the logs a bit carefully. So scrolling up to the absolute beginning, we can see that at the start, my model invokes with the Qwen3 14 billion parameter. This is my reasoning model. But since my query depends on a web search, notice that it is now executing the web search agent. So recall, if I scroll up, the web search agent is the name of my web search model. So scrolling down, we can also see that my Qwen3 8 billion parameter was invoked here, which is the same model that my tool model runs on. So far, so good. Let's now move on to build an image generation agent. I'll now create another tool. So my image generation agent will have multiple tools. So let's start by using the prompt generator tool, and it will be using a tool from the Hugging Face hub. So to do so, I'll go tool.from space and then my tool ID. So now let's find a tool that's appropriate for my prompt generation. So within Hugging Face, I find promptist, and my first link seems to be the one I want. So if you're curious what it is, it's just a tool that converts user queries into a more specific prompt that the model needs. So I'll copy this with the ID. I'll go back to my Colab and I'll paste it like so. Next, I would need a name. So name is my generator tool. and then my description. So my description is optimizes user input into model preferred input. Let's go to a new line, and now I want to import a tool for image generation. So let's name it image generation tool, and I want to load my tool like so. So load tool function, and then my text to image function, or my text to image tool. So let me find a new tool. So text to image Hugging Face. I can't find a tool. I'll need to find tool like so. So here I found a tool called text to image. So let's load it like so. I copy this and then I paste it here. Seems to be the wrong value, so I'll just do mric/text to image. And since this is running over a network, I would have to set trust remote code as true. Now I would need to fix my imports. So from Smolagents, import tool, and then load tool. Then my next step would be to create the image generation agent. So image generation agent will be my code agent. So the tools will be my prompt generator tool, then my image generation tool, comma, then my model name. So I'll use the Qwen3 14 billion parameter models, model get model reasoning model name, comma, and then the name and description. So I go to a new line, name image generation agent, comma, description, generates and saves images from text prompt. So my last step should be to link my reasoner model to my image generation agent. So I'll reassign my reasoning model like so. So reasoning model, and I'll just go up and copy the code like so. Scrolling up, I'll just copy this code, and then I scroll back down, highlight, and then paste. My manage agents is not just tool model this time, it will be my image generation agent this time. And now let's run it. I have an error. Let's see what my error is. So it seems like one of my tools is not working. Luckily there's another tool by another user, so it's Sergio, I don't know how to call it, pan equal, and let's run it again. So I have another error. Seems to be a client error, but here it also said the repository was not found. Let's now fix it. Okay, so I found my error. It's not mric, it's just a dash that comes in here in between, and then I run it again. Cool, as you can see, my code works. Let's now move on. If we want, we can even test out image generation agent independently. So I can do that like so. So image generation agent dot run, and then my query. So let's say a high res image of an independent hair shop repairing a MacBook display. So basically Apple's biggest nightmare. Then if I run it, I hopefully should see an image. So now a few minutes later, we have an output, but apparently we have an error. So according to this error, we need an API key to function. That's very much fixable. So what I'll do here, first I'll go to my Hugging Face hub. Within my profile, I'll first zoom in. Here within my profile, I'll go to access tokens, and then I'll create a new token. I would need read permissions, so let's call it collab multi-agent tutorial, and then I create token. So now what I do is I copy this token, and I go back here within my terminal. What I'll do is href to see if Hugging Face is installed. It is installed. I cleared this. So href auth login, then it will ask me for my token. What I'll do is I'll just paste it like so, and then enter. We can choose it as yes, and now my token has been saved. Now I'll close the terminal and then I'll run it again. Okay, so scrolling up, I now have my output, which is a weird image of a guy working on a MacBook. So before I ran my image generation agent independently, I would now like to test it with my reasoning model. So since I've passed in my image generation agent with my reasoning model, I can simply run my reasoning model like so. So I go reasoning model dot run, and basically the same prompt. So I copy this and I go back down, and then I paste it here. So if my reasoning model is smart enough, it will generate an image instead of doing a web search. Okay, so after a few minutes of processing, if we go to the output, notice that there's just text output. There is no image output. So I would need to create a new tool to save this image to the disk so that the user can see it. So now I scroll back up and then we create another tool. So here, let's just create another tool like so. So I simply go tool to create another tool, and then let's create a function called save image. So then my image will be an argument of type PIL. Basically, let me scroll down. Yeah, I'll just copy this type and then I'll paste it here. And this will also return the same type. And now what I want to do is I want to save the image to disk. So I'll create some documentation. So it's going to be takes the image generated by the tool and saves it locally. As for the arguments, it's going to be the image the image generated by the tool. I would now need to fix my import. So import PIL, and yeah, that's it. And as for my function body, I'll do image, so the image, and then I save it. Let's give the file name as out.png, and in the end I return the image itself. And now let's run our code sample again. Okay, so now it ran properly. Let's scroll back down and then rerun this code snippet. If everything works fine, we should hopefully see our image in the file explorer. Okay, so after a few minutes, an image has been built, but I don't have an output image within my file explorer. So I'll go back up. I realized what my issue was. I basically did not pass the save image to my tools array. So I'll pass in here like so, and then I run it again. So this time I ran my code snippet once again, and notice that it ran my save image function this time. It now has produced a PNG file. So if I click on it, hopefully I should see the same image. Nice. As you can see, our code works. Let's now close this and move on. So now I would like to test my reasoning model as well. So I run it. Okay, so after a few minutes of processing, I can see according to the logs that first my reasoning model ran, and then depending on the query, my reasoning model propagated that query to the image generation agent. Scrolling down, I get the answer saying that my image has been saved. So if I go to out.png, this time I have a generated image. Let's now create another code snippet to test if our web search tool works as well. So I'll simply go reasoning model.run, and then for my query, I'll simply go please tell me about the framework laptop 13 and generate an image of the framework laptop 13. So in theory, my reasoning model should propagate the first part of my query to the web search agent and the second part of my query to the image generation agent. So now let's run it and test it out. So after a few minutes, my processing has now been complete. It has now produced an image. So this is how the image looks like. Scrolling down, I'm not sure where they got the Pope age from, but notice if I look at the logs, it is actually performing web searches. As you can see, my reasoning model, if I scroll up, notice that my first part of my query was given to the web search agent and the second part of my query was given to the image generation agent. So this is how my web search agent has replied, and my image generation agent has replied by generating an image. Today, you guys learned how to build a multi-agent application, and you learned how to make them work together. That's it for today. If you guys have any questions, let me know. Till then, bye bye.